All right, part 2.
Yes.
Sure.
Okay, so both requirements are met. They're both over 10.
Well, all 4, right?
Yeah, all 4.
You're going to look at the P1 times N1, and then the N1 times 1 minus P1, and then N2 times P2, and then N2 times 1 minus P2.
Yes.
Annie, you look like you're not sure what I'm talking about.
No, I put it in and I thought I got it. I thought they were both over 10, but
No, they are. They're all over 10. All 4 of them are over 10. I just wanted to make sure you did.
okay. No, I thought you said that they weren't. Sorry.
No. I was just saying it's not 2 requirements. We actually had to check 4 different equations on this one. That's all.
Yeah.
Okay.
Okay.
Go ahead. Keep going.
B is N1 equals N2 and N1 doesn't equal N2 for the null alternative.
Except I just used P instead of N because N is sample size, so you just want to make sure.
Oh.
Confused.
I used the wrong letter.
P1 and P2.
Was P last week's, or was N last week?
I don't remember using N. I know we used that mu. Did we use N? I
don't know. I probably got my letters mixed up.
Okay.
Anyway, it's just P1.
But yes, you're right. Yeah, it's either equal or not equal to.
In this case, it's not equal to.
Okay, test statistic.
Well.
3.309.
Okay, perfect.
Very small
value.
0.001.
Yeah. Okay. So what decision will we make?
Reject.
Yeah, reject it. Because we have sufficient evidence to say there is a difference in the proportion of men who use labels and women who use labels. Okay. Number 5, confidence interval.
0.045 and 0.166.
Yeah. Interpret the confidence interval. What does it mean?
Well, we're 95% confident of the true difference in the proportions of the mean, or of men being label users and women being label users is between such and such and such and such.
That's right. Any questions on that? I thought it was pretty straightforward. What do you guys think?
Yeah.
Yeah?
Yeah.
Okay.
Basic principle being built upon.
All right, so open up the quiz
No.
if you haven't already. For questions 3 through 8, we will review, let's see, PTC tasting study with different data. Out of 70 females in the sample, 52 can taste PTC. Out of 59 males, 42 can taste PTC. Let P1 be proportion of females, P2 proportion of males. Is the proportion of females who can taste it different from the proportion of males? So I have P hat as 0.743.
Yes.
Okay. P2 hat is 0.712.
Yes.
Okay.
Uh-huh.
Our hypothesis is the second one, B, H sub O, P hat 1 hat equals P2 hat, and the alternative is P hat 1 does not equal P hat 2.
Yeah.
Okay. The 95% confidence interval for P1 minus P2 I have as negative 0.123, comma 0.185.
Yeah.
Uh-huh.
Okay. And with alpha equal to 0.05, what decision do you make? We fail to reject H sub O, right?
Mm-hmm.
Okay. Everybody okay with those?
Yeah.
Okay. All right, so looking at number 8, then we would say there is insufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true proportion of males who can taste PTC.
Yes.
Okay. Number 9 through 17. Mortality rates and day of admission heart attacks. Okay. So we're going to let P1 be number of patients or proportion of patients who had a heart attack and were admitted on a weekday, and P2 weekend. We're looking at a significance level of 0.05. We want to know, is the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die greater than the proportion of patients who have a heart attack and are admitted to the hospital on a weekday? So, are the conditions for conducting a hypothesis satisfied? I said true, they are.
Yeah, I got true as well.
Yeah, the sample sizes are so large that it made it greater than or equal to 10.
Mm-hmm.
Okay. Number 10, which set of hypotheses is appropriate for addressing the research question? I have the first one. P1 equals P2, and the alternative is that P1 is less than P2, or the weekends are going to be greater than the weekdays. Isn't that what they said?
Yeah, that's what I got.
Okay.
Makes sense.
Okay. So for number 11, I just plugged this into the categorical data analysis. So I got 0.141 for P1 and 0.145 for P2.
Yeah.
Yes.
So whatever you got. Yeah?
Yeah.
Uh-huh.
Okay, did you get a z-score of negative 2.020?
Yeah.
Yes.
Given the z-score from question 13, which should you shade, the left or the right? I think it's a left-tailed, isn't it, since it's less than?
That's what I think.
Okay. What do you think, Annie?
I wasn't sure on this one. To be honest, I put the right, but that was kind of a guess. Because,
Okay. I think when it's less
yeah,
than, we should go to the left. Drew, what's your input there?
Lean towards the left, just slightly.
Just slightly. All right. Well, I think when it's less than, we look at the left side. So I'm going to go with that.
Okay.
What is the p-value? I've got 0.043.
0.043.
I
Yeah.
got 0.978.
You got 0.978. What did you get, Annie?
I got 0.022.
Was it a 95% confidence level?
Oh.
Yeah.
It was? Okay. So I plugged in for X1 16713. Right? Will you look and see if you've got the same thing as me?
Okay.
Yeah. 16713 for X1.
Okay. N1 is 118519.
118519. Uh-huh.
Okay. X2 is 6155.
Uh-huh.
And N2 is 42447.
Uh-huh.
Oh, I see what it is. I put P1 is not equal to P2. I didn't put less than. Okay.
Okay.
Makes a difference.
That's
Yeah.
interesting. We all had different answers.
Yeah, p-value is 0.022 now.
Yeah,
Okay. That's what I have.
Okay.
works for me.
Okay. So then,
And I put rejectable.
yeah, but okay, but let me ask you guys something here because this really confused me. The confidence interval is negative 0.008 to 0. It includes 0, and I thought my understanding was if it ever includes 0, that we fail to reject the null hypothesis. If the confidence interval has 0 in it, then there's a good possibility that P1 does equal P2. So I was really confused with this one. Was
I'm
anybody
not
else
sure. I mean,
know that?
I've never really heard that before, but that does make sense, I guess.
It says whenever 0, it said in the lesson, whenever 0 is contained in the confidence interval, we conclude there is no significant difference between the two proportions. Anybody
they
remember?
will fail to reject then?
Yeah, but our p-value is small enough to reject it. So it's really confusing to me. Should we try and call Stephanie? Anybody have Stephanie's email?
I do.
Let's try and call her, see if we can get a hold of her.
I think, oh, yeah.
You better remember what her last name is. I might just be able to look her up.
Hunsler.
What is it?
Hunsler.
K-U-N?
With and a Z, I believe. Hunsler, right? Yeah.
Yeah, there's more than one. I think that's the one, though. I'm going to try it. It'd be kind of funny, though. Not her. But if you guys have an email, I'll do that one. There have been some of these where I've been confused. Oh, wait. She's joining us. Stephanie,
Hi, hello. I'm going to turn my camera because they got that light on back there.
we have a question for you.
Okay.
Hey,
Test my knowledge because you're one ahead of everybody.
okay. All right, well, we're on the quiz for two proportions, and I understand you may not be able to answer quiz questions, but this just confused us, and I wanted to clarify it with you.
Okay.
So we've done, we've calculated P1 and P2. We found the z-score. We found the p-value to be 0.022, and we're pretty confident that that's right. And so that's small enough that we would reject the null hypothesis. But on this particular one, in the categorical data analysis, our confidence interval is negative 0.008 to 0. So the confidence interval includes 0. So it's a little confusing to us because, of course, in the lesson it says whenever 0 is contained in the confidence interval, we conclude that there is no significant difference between the two proportions. So we're a little confused
Well,
about...
something's not quite right.
Okay.
So, somebody share your screen and let's check out the Excel sheet and see what we got going.
Okay, you guys want me to do that?
Go for it.
Okay.
Good one, dude.
Well, I can't really share my screen because I use.
Oh, because you're. So what do? You do it on the computer and then you pull the Hangout on your phone?
Yeah, I pull it up on my iPad and then I have everything else on my laptop.
No, just turn the iPad around. You got it.
Wouldn't be as high definition as say.
Yeah, it won't.
Okay, so here's the categorical data analysis. Here's the quiz, so you can see what numbers we're working with, make sure our numbers are right, although we've checked them against each other a few times. So it was out of 118,519 who had a heart attack during a weekday, 16,713 died. That was our P1 and our N1.
Okay, I lost my pen. Just a sec. 116.
I did notice if you up the decimal places so it goes beyond 3 decimal places, there is a 1 in there. So it's 0.00010.
Okay.
I don't know if that...
But wouldn't that be a positive, Annie, or is that net? It's positive, right?
It's a negative.
Yeah.
Oh, it's a negative 0.0001?
Uh-huh.
And that's being
Ah. Okay.
it actually goes further until 972
So we've
negative,
okay. So probably the answer is to reject the null hypothesis, but
probably.
we'll have you take a look at it, Stephanie, if you want.
So what? Double check your confidence level. What is that? 0.95.
Yeah, 0.95.
P is the weekday, P1. P2 is the weekend. On a weekend, greater than the patients who have a heart attack on a weekday. So weekend is greater. Yep, that's what you got. Okay, let me. So that's not the p-value. Oh, p-value. So it doesn't. Okay. It's not asking about the. So what do you want to do? You want to fail to reject? You want to reject?
Well, we want to reject it because the p-value is so small.
You're safe. Now
Okay.
tell me what your answer to 17 is.
There is sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die is greater than the proportion of patients who have a heart attack and are admitted to the hospital on the weekday who die.
Should work. So your p-value you put in was 0.022, right? I didn't look.
Yeah.
Okay.
Okay. All right. So the confidence interval just didn't go far enough.
Well. Here, let's see. But I remember the 0 coming into play, but your p is low, so you're gonna. Does the 0? It doesn't change it, does it? I can't. Sorry, I'm like reviewing with everybody.
No, you're fine. It just says if 0 is contained in the confidence interval, we conclude there is no significant difference between the two proportions. But my teammates are telling me that if we go out further in a decimal, we have like negative 0.00001.
Okay.
So technically,
So, I kind of remember that. So you might take your Excel sheet and, oh, that was too far. I think I deleted my originals. I think we may have highlighted those two and increased the decimals so that we could see it.
okay.
And just don't save it with your data in there. Like, clear your data and then save it as it first comes up. Change that and then save it, so that that's the only change that you make to the whole thing. So fresh start, open it, increase your decimal, and then save it.
Okay. Okay. All right. Anybody have any other questions for Stephanie?
Nope.
I'm good.
Okay.
And you cut your hair off.
Yes.
Bet that's a change.
I got a problem wrong on here.
You have what?
Oh,
I
you
got
already
one of the answers. Yeah, I got number 5 wrong.
ask Stephanie about this. Okay, wait, this has got to be right, so that I don't understand why that would be. Oh, wait, did you put, oh, it shouldn't be p hat. It should be without the p hat.
It's just regular P's.
P1 equals P2, and P1 does not equal P2. And we should have known that. We should have caught that because it's the only one on there that has a p hat.
One of these things, just not like the
Yeah,
other.
sorry, guys.
So
Okay.
some of you chose B and some chose D.
Yes.
Oh,
But we know now. Yeah, when we're looking at, I know I made that mistake actually on the homework too, Annie. When we're looking at
Oh, really?
yeah, when we're looking at the null and the alternative hypothesis, we're looking at the actual p-value, not the sample p-value. Sorry.
Cool.
All right, you guys. So, Stephanie, you don't have to stay on if you don't want to.
okay. Are you going to do your group?
Project. We're going to talk about the project on it.
That.
Okay. Awesome. I haven't looked. Has he graded your design the study yet? Somebody turned one in. I think it was your group.
Did you already turn it in?
I did not.
Okay.
Okay, maybe it's not you. I just remember seeing one as I flashed through a screen, and so it may not be yours.
Okay.
But you guys are usually.
So, do you want to tell us your opinion on ours?
I don't know. I don't want to influence you because with my instructor, we had kind of a hard time. This was like the hardest part was getting him to approve them because he doesn't want, well, this isn't the same instructor. He didn't want them to be too hard, but they had to fit the criteria too. And so,
Ours is pretty easy.
okay,
But-
let's hear it, and I'll see. I don't want to influence you though.
Yeah, it might be too easy, so maybe you should tell us.
It does have variety, though.
What? I didn't hear what Drew said.
It's favorite season, and we're just going to go to Facebook and ask for people to do input on their favorite season, and we're going to try and collect at least 100 from each person.
Variety.
Too simple, huh?
I wouldn't say it's too simple. I'm worrying about how you're going to. So, what's your population? What's your?
So we're saying population would be Facebook users. We could change that, but I figure we all have a random sample, really, of Facebook users as our Facebook friends. It's not like our friends would have a different favorite season or be a bias towards a particular season. This is my thought. I don't know.
So, the way my instructor explained it to us, to walk into the store, a lot of people do M&Ms. So to walk into the store and just grab a bag of M&Ms isn't really random. Random really does have a pattern, although in your pattern, the people you choose are random. Does that make sense? Well, when people say I got a few random things at the store, it's really not random. If you go back to the stratified and all those different definitions, you'll see that they're not just go grab one and that's your sample. Let me look at the book really quick and describe the one I'm worrying about. And you may be able just to tweak it a little bit and make that work. That would be my thought that he would have a problem with is how you collect your data.
Mm.
Convenient sampling, that's the word.
Yeah, we're trying not to do that, but I didn't think we were since I don't feel like. I mean, I guess it is convenient, but a lot of I don't know.
I don't know. Okay, so one thing that you might can do is say, let me look at them and let me see which one I think. I gotta find them first.
My thought was using stratifying randomization, getting a certain number from each of us, and then randomly choosing a number, say 20 from each of us that collect data.
So you could say that your groups of homogeneous similar items, your like Annie's friends are one strata, Drew's friends are another,
Yep.
so that you each have your friends, and then you're pulling 100 samples from each of your friends. 100
Total.
Mhm.
like variables, you know, because yeah, data
Okay.
points, whatever you want to call it. That you might can explain it that way and make that work.
Okay. All right, Drew. Good luck.
Brother Paulson's picking up his daughter tonight from the airport. She was in Sweden on her mission,
Oh, how neat.
so he just texted me that it was Sweden that she's coming from. I think that would be my only.
Okay.
We can give it a try.
All right.
So what test are you going to use?
So I thought we'd use proportions testing. I mean, we could pretty easily make a pie chart out of that.
Yeah.
Okay. So
But I don't know.
don't remember what we were going for, because we were working on ours before we learned ANOVA. And so I'm trying to think how that would work out.
Well, next lesson is multiple proportions. So I don't know if maybe we would want to go there and look at summer, winter.
Tell me your alternate hypothesis.
So our null is that summer would be picked the most, and the alternate would summer would be picked the most.
Okay, so doing it that way,
Huh?
I'm wondering if ANOVA should be the one that you choose,
That makes sense.
because one would be different, you know? I don't know.
But then if we do that, though, we couldn't use summer as our null hypothesis. We would just have to.
Are they all the same, or is one different? Is there one that's
Yeah, but winter and
preference?
spring could be different from each other, and then that's not really rejecting the idea that summer is going to be the most.
Yeah, it would have to be they're all equal, or one is different. Let me.
Oh, yeah, but
Let me.
we already have a pretty good idea that it's going to be different.
Which you're not. You're gonna guess it, huh?
Yeah, I
Oh,
guess
you know
you're right.
what? We didn't use ANOVA. We used the chi-square test. That's what we used. I lied. Okay, so so our theory, our group project was we each went to a store and we bought 3 boxes of the theater size Reese's Pieces. And so we had one person in Pennsylvania. She went into Delaware and Ohio and bought us ones from those states. And then we had a Northern California and a Southern California and an Idaho. And we each counted, and our theory was that the colors would be the same. and but then we counted the colors in the Reese's Pieces and filled in
Were
the
they?
squared. You'll learn about the chi-squared. It may fit there a little better, but turn it in and if he does like Brother Bennett, he'll just give you some feedback and you can go tweak it a little bit. That's why you've got extra time. So send it in and see what he says.
Okay. All right, thank you, Sexy.
That doesn't seem too different than counting the colors. No.
Okay.
One more.
Yeah, we just need to get it approved quickly because we need some time to have people respond to us.
Oh yeah, yeah. It didn't take long to go
Buy the cans.
candy and count it
Yeah.
out. It was the hardest part, telling the kids, stay out of it till my group project's turned in.
Yeah. I know. We could do that, guys. If you guys want to do candy, that's okay. I'll do it. I'll just give it to my young women or something.
Well, you can try yours. I think that's pretty interesting to see. And then you have a quick backup if he says no.
Right.
But if you can figure out how to make it fit the criteria, then you're fine.
Okay.
So, turn it in, give it a try.
Okay.
If you're in a crunch and need to tweak a candy one, let me know. Ours was a lot different than what most everybody did. Most everybody would say there's an equal number of colors in... No, they would say there's one color more. I can't remember. I should go see if I can find some videos from his office hours and watch them again. Because we talked about the group projects quite a bit in our office hours last semester. Maybe I'll do that, then I can be a little bit more help with the projects.
You've been
He was
helpful.
just
Thank
so
you.
picky. Huh?
Thank you for helping. You've been helpful.
Well, I try the Facebook thing because
Okay.
you've got a way to keep sample and you've got it all thought out. So turn it in.
All right.
It says. Okay,
right.
I'll let you guys finalize it and get it ready. Okay.
Have a good night. Thank you.
Okay.
All right,
And
guys.
one of us turns in the paper, right? For the design of the study, we don't all have to submit it, correct?
I think just one person, but I haven't seen
Okay.
any details.
Yeah. Yeah, it's just one person, I think, too.
Okay. Cool.
I did
But we
this-
do need to decide what kind of hypothesis testing we're going to use. So I thought we would use proportions, but I don't know if you guys think that's going to work or not.
I looked at the rubric and it didn't really ask for that. It just asks for things that I wrote down, which were what the population is, what the null alternative hypothesis is, what sampling method you used, detail how your group collects the data, what the sample size is.
Okay.
So maybe we don't decide what hypothesis or what type we're doing until after we kind of gather the data or develop it a little bit more so we can figure out what would be best.
Okay. All right. I think proportions would be good personally because I think we're going to have a proportion. But
Yeah.
I'm game for whatever. But
One
I
proportion?
think, yeah, and I think maybe the answer is that we do 3 proportions. We compare summer to winter, we compare summer to fall, we compare summer to spring, and we see whether or not it is indeed the biggest. But I don't know. Next week, or is it next week? Yeah, next Tuesday we're going to go over several proportions, so it may be that fits better, but I'm not sure that it would. So.
Yeah.
Okay. All right, Drew, do you feel like you have any questions? Do you feel like you know what to do?
I just wanted to solidify what I needed to have down here because I have those things down. I don't know if they're the right things to put down.
Okay.
So what were we saying the population is exactly? Do I need to throw in a number?
So we're gonna say Facebook users,
Facebook users?
right, guys? Does that
Yeah.
sound okay? Okay.
Yeah, that's what I wrote down. Facebook users.
Okay. The null hypothesis, unless we've changed it, it would be that summer would be the most picked.
Yes.
An alternative is summer is not most picked. In other words, not equals.
Yes.
Okay.
Mm-hmm.
And then for sampling method, which we haven't really talked about yet because it was just brought up barely, I think stratifying would be the best, but I don't know.
I'm fine with that, Drew. That's fine.
Okay.
So what you're basically saying is that we're gonna have like clustered samples, you, me,
Yeah, we're
Annie,
gonna
Bert.
pick a certain number from each of us. Say if we get like 100 people to answer our question, we take like 25 from each person.
From each randomly. Okay.
Yeah.
That's what stratify. We divide it into strata or groups and then randomize
Right.
them.
Okay.
Okay. And then let's see, what was the other question? Describe in specific detail how your group will collect the data. So we'll post the question up on social media and go
Yeah.
from there, right?
Yeah.
And what's the sample size?
I guess we're gonna do 100.
25 from each person?
You guys wanna do that?
Yeah.
Okay.
Is better.
Yeah, 100.
Okay. I guess that's about it. Has anybody else started, like posted this yet?
Well, I didn't want to post it
No.
until it got approved.
Okay.
Yeah.
Yeah, number 7 says.
Yeah. Okay, guys, let's have a plan B. Let's just like get dots boxes or those little dots candies.
Oh, okay.
Yeah.
See if they have the color. I mean, that's an easy one. I think this would be fun, but if it doesn't get approved, we'll just have that as plan B. Does that sound good?
Mm-hmm.
Okay. All right then. Have a good night. Drew, let us know if you run into any trouble, and please let us know as soon as you hear whether it was or was not approved, so we can go ahead and either move forward, or change it.
I think
Okay.
I'll get it tonight.
Awesome. That'd be great. Okay. Thanks you guys so much, and yeah, just let us know, and we'll see you on Tuesday.
Okay.
Okay. All right. Take care, you guys. Thank you.
Bye.
Bye bye.